What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video I'm going to talk about the law of cosines, which is a cool tool we can use to solve triangles. And it pretty much works where the law of sines fails. So that's how I go about solving triangles. First I look to see if it's a right triangle. If it is, then I can just use my trig functions. I can use Pythagorean theorem. But if it's not, then first I look to see if I can use the law of sines. Can I find a side and an angle that I can compare and solve for another side or angle, right? And if that doesn't work, then that's where the law of cosines comes into play. So this is used to solve side, angle, side, and side, side, side triangles, okay? But you really don't have to memorize this. I personally don't. Again, I just go through that process of investigating and seeing what's going to work. But these are the formulas. You do probably have to memorize these. But the cool thing is you really only have to remember one of them, right? Because if you know one, you can kind of think your way through to find the others if you notice this pattern. So whatever side is out here on the left side of the equation, right? Whatever side is out here always matches up with the angle, and that's how I remember it. And then whatever's left in here are always the remaining sides, okay? So here we have a squared out here to the left, and here we have cosine of angle A, so those line up, and then everything else left are B's and C's, okay? So that's how I personally remember it, and that helps me to remember. And that way you can just kind of remember the form of one of these, and you can kind of swap out stuff and come up with the rest when you need them. So let's go ahead and jump into some examples and see if we can solve some triangles. All right, let's start with our first example. And by the way, law of cosines tends to be easier than the law of sines, mainly because we don't have to worry about any ambiguous case. Pretty awesome, right? Ambiguous case is like kryptonite to students, I swear. So law of cosines, here's our example. We have side A, side B, and angle C. This is a side, angle, side example. And hopefully it's clear that we couldn't use the law of sines even if we wanted to, because to use the law of sines, we have to have a side and a corresponding angle that we can use to compare to another side and angle, and there's no way for us to get that. So we have to use the law of cosines, okay? So which formula do you think I'm going to use? Well, I'm going to use the one that includes side A, side B, and angle C, right? So that's the one where I have C squared out here in front to the left, and then I have A squared plus B squared, remember these are just the remaining sides, minus 2 times A times B times cosine of C, okay? So what I'm going to end up solving for is side C when I use this formula. So let me go ahead and copy the stuff down. C squared equals, let's see, our A is 2, so I have 2 squared plus 3 squared minus 2 times 2 times 3. Ooh, cosine of 60 I actually know without using a calculator. That's pretty nice. All right, now let's see if I can evaluate this. 2 squared is 4. So let me see. C squared equals 4 plus, this is 9, minus, let's see if I can figure this out. 2 times 2 is 4, times 3 is 12. Let's see, so 12 times, what's the cosine of 60 degrees? That's 1/2, right? 12 times 1/2. So let's see if I can simplify this a little bit more. This becomes 13, all right? So I have C squared equals 4 plus 9, that's 13, minus 12 times 1/2, that's 6, which equals 7. So that means that C squared equals 7, so C equals the square root of 7. C equals the square root of 7, and again, positive square root, I don't plus or minus because these are side lengths, right? So C equals square root of 7, and if I want to, I can punch this in a calculator to get an approximation. All right, so when I punch this in a calculator, I get approximately 2.65, so I can go ahead and add that here. Side C equals 2.65. And now what do I have? I have side A, B, and C, and angle C. So now I can actually use the law of sines because I have a side and a corresponding angle that I can use to compare to another side and angle to solve for, let's say, angle A. I can use that to solve for angle A, right? So that's the cool thing about using law of cosines, is that usually once you use law of cosines once, it opens you up to be able to use the law of sines after that, and you still don't have to worry about that ambiguous case. We don't have that. So let's see, I can use sine of 60 sine of 60 over 2.65, right? That's sine of C over C equals sine of A over 2, all right? Now if I just multiply both sides by 2, I get 2 times sine of 60 over 2.65 equals sine A. Now I need to sine inverse both sides, okay? And if I sine inverse both sides, I'll have to punch that in a calculator, but I sine inverse this guy. If I sine inverse this, that cancels, and I'm left with angle A equals the sine inverse of whatever this value is. So you can punch this in your calculator first and then do sine inverse of that, or you could just type in sine inverse of this whole thing. That's usually what I do. Either way, whatever works best for you. So sine inverse of 2 times sine of 60, which is, by the way, that's just what? Root 3 over 2. So you could do that too. Over 2.65. Now let me go ahead and punch this in a calculator and see what I get. I get 40.81. All right, so my angle A is 40.81 degrees. So now I can find angle B really easily, actually. I don't have to use law of sines again. I know angle A and angle C, so I can do 180 minus angle A and angle C and solve for angle B. So I'm going to do 180 minus 40.81 minus 60, and that equals what? Let's see, 79.19. All right, so this is angle B, 79.19 degrees, and I have now solved this triangle. I have angles A, B, and C, as well as sides A, B, and C. So let's go ahead and do one more example. All right, let's look at another example. This time we were given 3 sides, and we were asked to solve this triangle. So we are going to use the law of cosines. Clearly, we can't use the law of sines, right? Now, which of the 3 formulas do you think we're going to use? Well, we can use any one we want, right? Because we're given 3 sides. All of those formulas involve the 3 sides. So which angle we solve for just depends on which of those we pick, and it really doesn't matter which one we use. We can solve for any of the 3 angles. There's no reason we would choose to solve for one over the other. So I'm just going to pick C. I'll solve for angle C. So I have C squared. Let me write out the formula first. C squared equals A squared plus B squared minus 2AB. Almost forgot. 2AB times cosine C. All right. So now let me fill in the blanks with this information. I have 6 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of C. So I am going to end up using cosine inverse, right? But first I need to isolate this cosine C. So first let me evaluate all this stuff. I get 36 equals 16 plus 9 minus, let's see, 2 times 4, that's 8 times 3, that's 24. So this is 24 cosine C. Now let's see, 16 plus 9, that gives me 25. So I have 36 equals 25 minus 24 cosine C. Now I can subtract 25 from both sides. So I end up getting, let's see, if I subtract 25 from both sides, I get 11. So let me draw an arrow here, be efficient with my space here. 11 equals, let me make sure I'm doing this right, 11 equals negative 24 cosine C, all right? So now I can go ahead and divide both sides by negative 24. And when I do that, what I'm left with is cosine C equals negative 11 over 24. Cosine of angle C equals negative 11 over 20. I just moved the negative from the bottom to the top. I can do that. It's fine. I just prefer it in the top, so that's why I did it. And don't be alarmed that this is a negative. That just means that we are in the second quadrant. So this angle C is going to be between 90 and 180 degrees. So let me go ahead and cosine inverse both sides. Cosine inverse, right? So that gets rid of the cosine. Since I'm solving for an angle, I have to use the inverse. And I have C equals cosine inverse of negative 11 over 24. And if I punch this in a calculator, I should get 117.28. 117.28 degrees. So my angle C is 117.28. So I have my first angle I solved for. Let's see, angle C equals 117.28. So now I can use the law of sines to solve for a second angle, and then I can do 180 minus both those angles to get that third angle. As you can see, it's a process, but we only really have to use the law of cosines in the first step of these problems, where we have side, 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 or side, angle, side. We only need to use it once. So I'm going to go ahead and use the law of sines now. Let me erase and make some room. So now I can use the law of sines. I can do the sine of 117.28. So that's sine of angle C, 117.28 over 6. So sine C over C equals sine of, it doesn't matter which one I choose, I'll choose A. Sine of A over 4, all right? So I'm going to multiply both sides by 4 so I can isolate the sine of A, and then I can take the sine inverse of both sides. Hopefully this is familiar by now. Hopefully you're feeling comfortable with this stuff by now. So 4 times sine of 117.28 all over 6. This equals sine A. And now I sine inverse both sides. Sine inverse. I'm moving a little quicker now because, again, cancel, cancel. We've done this quite a few times now, so hopefully this is you. You worked the problem out ahead. You paused the video. You tried it. You got it. And now you're checking your answer. That's my hope. What everyone's doing. Okay, A equals sine inverse of 4 times. Let's see, 4 times sine of, and again, you could have punched this in a calculator beforehand instead of just plugging it all in at once. That works fine too. A lot of students prefer to do that, so that's cool. What does this equal? Let me see. Do I need a calculator? 36.34 is what I get. 36.34 degrees. So this is what angle A equals, 36.34. So now I have 2 angles, so I can easily solve for the third angle. So angle B equals 180 minus 36.34 minus 117.28. So what does this equal? I think I will need a calculator for this. All right, I get 26.38 degrees. So I have finished solving this triangle using the law of cosines. I have found angles A, B, and C. I was given all the sides. So I found all the angles using the law of cosines and then going back and using the law of sines again. So hopefully this video helped. If you enjoyed it, make sure to hit like. If you have any questions at all or any suggestions, comments, anything like that, please leave them below. And stay tuned for the next video. Hit subscribe if you don't want to miss what's coming up next. But most importantly, make sure to keep flexing those brain muscles.